Good morning. Welcome back for 10.2. Today we are going to be working on converting coordinates. So if we're given it in polar coordinates, we can change it to rectangular, or if we're given it in rectangular, we can change it to polar. Okay. Now, first off, rectangular coordinates, this is like our standard XY. Another name for this, sometimes you might hear it referred to as Cartesian coordinates. Okay. So our XY coordinates, remember with rectangular coordinates, each spot has one specific set of coordinates that gets us there. Where with polar coordinates, that's not always the case, or it's not the case. If we have a negative radius or a negative theta or various other things, there can be numerous answers for the same spot. Okay, so if we are given something in rectangular coordinates, an x and a y, we can plug it into these ones on the right to find what our theta is and what our r is. If we're given an r and a theta, we can plug it into these problems on the left, and we'll be able to find what our x and our y are. So to start off on the front side here, it says convert each polar coordinates into a rectangular coordinate. So keep in mind, it looks the same whether it's in polar or rectangular. So it's important you look and see if it tells you which one you have. And then we're going to express our answer in simplest radical form. So this first one, 6 pi over 6. So we're going to plug those in to solve for x and for y. So to solve for x will equal, it's r, which is 6 times whatever the cosine of theta is, which in our case is pi over 6. Likewise, y will equal the same thing, except instead of cosine, you know y is associated with sine. Okay, now in case you forgot, pi over 6 on the unit circle is right here, so cosine will be square root of 3 over 2, sine will be 1/2. So we go back here, and I'm going to rewrite 6 as a fraction, so 6 over 1 times, we said the cosine of pi over 6 was square root of 3 over 2. If we multiply across that, we'll get 6 square root of 3 over 2. If we simplify, we are left with an x value of 3 square root of 3, because that 2 goes into 6 3 times. Okay, we can reduce. Now for the next one, 6 times the sine of pi over 6. Sine of pi over 6 was 1/2. So if we multiply, that'll give us 6 over 2, which we know reduces to 3. And our final answer then, 3 square root of 3, comma 3. So that would be our final answer in rectangular coordinates. All right, next one, same thing. Once again, x will equal 5 times whatever that cosine of 0 is. Y will equal 5 times whatever the sine of 0 is. So hopefully you remember the cosine of 0 is 1. So 5 times 1 over 5. Meanwhile, the sine of 0 is 0. And the point will give us 5, 0. And what I want to show you is, so 5, 0, if we go up here to our coordinate, if the theta is 0, it stays here, and out 5 goes out here. And that's the same spot as if it was in rectangular, just 5 to the right, up 0. So you can see what we're doing. Okay. So we'll practice a few more. If you feel like you know what's going on, go ahead. You can pause it and try it on your own. So for our next one, x will equal 4 square root of 2 for cosine of this 7 pi over 4. Meanwhile, y will equal 4 square root of 2 for the sine of 7 pi over 4. And so if we look on our unit circle, 7 pi over 4. So down here, square root of 2 over 2 for cosine, negative square root of 2 over 2 for sine. So 4 square root of 2 over 1 times square root of 2 over 2. Where this one will be 4 square root of 2 over 1 times negative square root of 2 over 2. So across the bottom is easy. 1 times 2, that's clearly 2. Across the top, think of it as 4 times 1, and then square root of 2 times square root of 2 gives us 2. So 4 times 2, that total will be 8. Hopefully you know 8 divided by 2 gives us 4. Meanwhile, over here, same thing, a 2 on the bottom. Everything's the same except there's a negative right here, which causes this to become a negative 8. And so our final answer then for y will be negative 4. So if we write this as an ordered pair, we will get 4, negative 4. Okay, final one going this way. If we look here, we've got x equaling 8 square root of 3 times the cosine of whatever 2 pi over 3 is. And then we also have y equaling 8 square root of 3. Same thing, except instead of cosine, it's the sine of 2 pi over 3. So we go to 2 pi over 3. Right here, 2 pi over 3, so negative 1/2, and then square root of 3 over 2. So negative 1/2, that will give us negative 8 square root of 3 over 2. The 2 goes in at 8 4 times. So our final answer is x equals negative 4 square root of 3. For the y, 8 square root of 3 times, it was square root of 3 over 2. This one will equal, so it would be 8 times 3 on top, all over 2. 8 times 3 is 24 over 2. And so hopefully we can see we'll get y equals 12. All right, so that is how we go from starting in polar to get to rectangular. Now flip it over to the back, and we're going to go the opposite way. To do this, we'll need to use these values. Okay, so to find r, it's kind of the same idea as like Pythagorean theorem, essentially. We will find what that radius is. And so if we think about it, for this first one, r squared is going to equal negative 1 squared plus negative square root of 3 squared. So if we do this, negative 1 squared becomes 1. Negative square root of 3 squared. Negative times negative is always positive. Square root of 3 times square root of 3 becomes 3. So r squared equals 4, and hopefully you know square root of both of those, we will get 2. Okay. Now, technically we could get negative 2. We are going to find these for the positive value of r today. Okay. So if we look here now, to find what theta is, tangent of theta equals y divided by x. So I'll write tangent of theta equals, now the y is negative square root of 3 divided by the x is negative 1. The negatives cancel, and our square root of 3 over 1 is just the same as square root of 3. So I look, where is the tangent of theta equal to the square root of 3? Now here's the thing. That occurs at 2 points, up here in quadrant 1 and down here in quadrant 3. So we have to look, and in our situation they're both negative. So I should have done this first, but if we start at the origin, that's going to be left and down. It's somewhere down here in quadrant 3 we know. So we go back here, somewhere in quadrant 3, and the only place that occurs, 4 pi over 3. So theta has to be the 4 pi over 3. All we got to do now is write it as a coordinate. So 2 comma 4 pi over 3. And that is our answer. All right, example 6. So this time we're dealing with 5, 5. Okay, so to start off with, we can do 5, 5 somewhere up here in quadrant 1 we know. So let's find what r squared is. It's going to be 5 squared plus 5 squared. We know that 5 squared is 25. Okay, we add those together, we get 50. Now the square root of 50 actually can be reduced. We know that's 5 times 2, pair of 5s. Okay, so r is going to equal 5 square root of 2. To find what our tangent is, we'll do tangent of theta equals y divided by x, so 5 divided by 5. So that means the tangent of theta equals 1. This will occur when theta could occur at two different spots. When is tangent of theta 1? Occurs over here at pi over 4. It also occurs here at 5 pi over 4. We know it's up in quadrant 1 because it was the point 5, 5. So pi over 4 is our answer. And all we have to do then, 5 square root of 2, comma, pi over 4. All right, let's do two more of these. If you want, you can pause it and try on your own. Once again, let's think about where this will lie. So left and then up, somewhere up here in quadrant 2. To find what r is, negative 6 squared plus whatever 2 square root of 3 squared is. Okay, so negative 6 squared becomes 36. 2 square root of 3 is the same as 2 square root of 3 times 2 square root of 3. So 4 times 3. Because 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So that's going to be 12. So r squared equals 48. If we take the square root of that, this can break apart. We know it's 4 times 4 times 3. 4 times 4 is 16 times 3 is 48. I could keep breaking those apart to 2's, but we already have a square here, a 4 and a 4, so I'm just going to circle them. So r will equal 4 square root of 3. Okay. Now, to figure out what theta is, tangent of theta equals y over x, so 2 square root of 3 over 6. The 2 and the 6 can cancel. We're left with square root of 3. Sorry, it was negative 6, so we're left with negative square root of 3 over 3. We know it's in quadrant 2 and negative square root of 3 over 3. So we go over here, negative square root of 3 over 3, 5 pi over 6. Okay, we're just about done. Final one. This last one, once again, let's think about where it exists. So to the right and down, somewhere in quadrant 4. If you're not sure how to get that, x is positive, so it goes to the right. Y is negative, so it goes down, somewhere over here. Now, to find r squared will equal whatever the square root of 2 is squared plus negative square root of 2 squared. So square root of 2 squared becomes 2. Square root of negative 2, or negative square root of 2 squared, becomes 2 as well. Because negative times the negative is positive. Square root of 2 times square root of 2 is 2. Okay, so r squared will equal 4, and we will get r to equal 2. Now to find tangent of theta, we just take tangent of theta equals y divided by x. The square root of 2's will cancel, and we will be left with tangent of theta equals negative 1. We know it has to be in quadrant 4, so negative 1 down here in quadrant 4 is 7 pi over 4. So that's what theta equals, and all I need to do now is write this as a coordinate. So today there is a Delta Math assignment. Go ahead, try to get that done. I think I asked you to do 3 of each of these, so give it a go. If you need help, let me know, and hope you guys have a great day.